Welcome back, guys. Now I'm going to talk about the 4-point balance method. The 4-point balance method is quite simple. It only requires the accelerometer mounted on top of the inductive fan unit and the connection to the PC. So I'll just pan over to the right to show you what we need in terms of the software. So the software required is essentially the oscilloscope software, as well as the 4-point balance tool. The 4-point balance tool can be downloaded from the website, and it's just the Excel sheet which we use to enter the data when we do the balance run. And there's also a chart on the right hand side, and we'll discuss how we actually use that to get the final balance. Now, just to provide an overview of the 4-point balance, essentially what we're going to do is run the inductive fan unit in its normal state without any trial weights, and we just want to measure the initial vibration level. And then what we're going to do is we're going to take a predetermined weight, which can be any weight you choose, preferably under a gram for this type of run, and apply it at 3 locations equally spaced around the hub of the inductive fan unit. Okay, so now we can actually spool up the inductive fan unit at the test frequency. In this case it's 40 Hertz. So I'll get that started. Okay, now the initial vibration level can be measured directly off the oscilloscope, and again it's the peak to peak voltage that we're interested in. In this case the peak to peak voltage is registered as 14 millivolts. So now we can go to our 4-point analysis tool and enter in 14 millivolts as our first amplitude for the vibration level. The next step in the spreadsheet is to determine the trial weight. Now again, this can be any weight you wish, preferably something below 1 gram for this particular run. So I'll spool over to the left and take the scales, turn them on, and I have a weight here, and put that on scales. So my trial weight ends up being 0.304, or roughly 0.3 grams. So we're going to enter that into the spreadsheet. Now we can apply that 0.3 grams at the 0 degree reference position and spool up the inductive fan unit at 40 Hertz and again measure the vibration level. Once we have that level, we can apply it in the spreadsheet directly below the trial weight. So I've applied my trial weight at the 0 degree reference position, which coincides with the white marker on the hub of the inductive fan unit. So now I can spool up the inductive fan unit at my test frequency of 40 Hertz and again measure the vibration level. Once we have that level, we can enter that in the next location in the spreadsheet. So here is the resulting vibration level for the first trial weight run, and measuring the voltage peak to peak, it comes in at 21.27, roughly 22 odd millivolts. So now I can enter that value in the next cell of the spreadsheet. which will go here, and then proceed to the next trial run, which would be at the 120 degree setting. Okay, now I've applied the trial weight at the 120 degree position, so that's moving in a anti-clockwise direction. So I hit the 120 degree mark and place the weight there. So now I'll spool up to the 40 Hertz target frequency, and again measure the vibration level and enter that into the next cell of the spreadsheet. Finally, I apply the trial weight at the 240 degree position, which lies at this location relative to the white marker. So again, I'll spool up to 40 Hertz and measure the vibration level. Once I have that, I'll enter that into the next cell on the spreadsheet. So now I've entered the vibration levels for each of the 3 trial balance runs. So the first run was 21.27, 18 and 33 millivolts. Once you've entered those values, you'll see on the right hand side there's a chart which has 4 circles. The first circle, which is a green dotted circle or hash circle, is actually the original run for the vibration level, and that's without the trial weight. The next circles you'll see will be the red circle, which is the first trial run with the trial weight. The next run is actually the blue circle, which is the trial run at the 120 degree location. And the final circle is the orange one, which is actually the 240 degree location of the trial weight. Once we have those values in place, you'll find that the red, blue and orange circles will coincide or intersect at a common location. Now, in a perfect world, you'll actually find that these circles should actually intersect at one point. However, due to errors during measurements, and also errors in locating the position of the trial weight between each run, you probably find that the circles won't coincide perfectly. However, what they will do is they will actually bound a triangle as shown on the screen. So what you want to do to determine the final balance solution, you can actually use these markers on the right hand pane and also on the bottom of the chart. If you click on them, it will actually move the black marker or the black dot, and you want to position that black dot in the center of the triangle. So I've gone ahead and done that, and if you go to the left hand side, you actually see the balance solution. My balance solution says I need to apply 0.2 grams at a location of 67 degrees from the 0 reference position, and that completes our balance for this operation.